Hello everyone, welcome to our lesson on linear approximation. In this lesson we will cover objectives, learning objectives, writing an equation of a tangent line to a curve and point slope with the aid of differentiation. We also use the tangent line to approximate function values at points on at least 3 functions. These are the big ideas embedded in this lesson. The use of the tangent line of a function to approximate the function values, using linear approximation as an easier approach to estimate function values. Since we utilize linear function to evaluate functions that are more complicated. And then the tangent line can also be used to determine overestimates and underestimates depending on concavity of a function on any given open interval. Next, we look at the relevant prior knowledge that students bring to this course, to this unit. Students who have demonstrated mastery of finding derivative of a function, writing a linear equation in point-slope form and slope-intercept form, and lastly finding equation of a tangent line from any given point on a graph of a function. The materials we need for this lesson include textbook, which will serve as reference for some of our practice problems, graph paper, straight edge, pen or pencil to write with. We'll also use some technology, the graphing calculator, the TI-84, and the emulator. And we'd also use Screencast-O-Matic as a recording tool. And then lastly, we'll use Desmos graphing calculator to explore and investigate function values and tangent line values and errors of approximation. So here's our graphing calculator we'll be using to explore some of our functions as we draw the tangent line to them and evaluate those function values and tangent line values. This will be our lesson opener, our warm-up. Is this question: so write an equation of the tangent line to the graph of the function f of x at a point 1, 0. Then verify your answer graphically with the graphing calculator. So I give you a minute or two to see what you can do with this problem, and then we'll share my solution. Okay. So our strategy for this problem is to find the derivative of the function and evaluate the derivative at 1, the x value, and that derivative then becomes slope of the tangent line. And with the slope and the point 1, 0, we write the equation of the tangent line. So step 1, we see the derivative and evaluate at 1. That gives us 2, so our slope of the tangent line will be 2. So we write our equation in point-slope form and then simplify, and here is our result. Now, we'll be able to verify this in our graphing calculator. So let's pull up our graphing calculator and turn it on. So here are 2 functions in there. Let's say graph. And we see the tangent line drawn to the cubic function. Now let's verify what a point of tangency is. And so with our arrows, we can go close enough to the point of tangency. If we trace at 1, the output gives us 0, which confirms that a point of tangency as given in the question 1, 0 also shows on the graph. Okay, now we get back to our slides and let's go. Okay, so Okay, so here we have a graphical exploration. Students would get your mobile devices, and let's go to this link, and you're going to evaluate the function values and then the tangent line values. We would find what difference it makes as we go away from the point of tangency. So I have some points already plotted on here, but students will be able to also plot some more points on the graph and verify the differences between the function and then the tangent line outputs. So in here, the closest point to the point of tangency, we have the point of tangency at 1, 0. Now we can evaluate there's 2 points on the tangent line, and on the function, we find the difference between 0.288 and then 0.4 as quite minimal compared to these values here. If we look at the output here on the tangent line, we have -0.8, and then on the graph we have -0.3. So students will explore this function values and then the tangent line values, and then compare those values and be able to determine that as we get farther away from the point of tangency, the difference between the function values and the tangent line values get bigger. So if we want a good approximation, then it behoves us to evaluate a point that is close enough to the tangent line, point of tangency on the graph. Okay, now let's go back to the slides. So next, based on this activity, students will be able to define what linear approximation is. Here we have our definition that if a function f is differentiable at a point A, then the linear approximation of the function at af of a is the linear function L of x, f prime of a, x minus a plus f of a. This is derived from the point slope form of equation of a linear graph. So this diagram here reflects definition, and we will use this definition now to solve some problems. So first, our guided practice problem, we'll go through evaluating f of -3.1 using the tangent line to the function f of x. So let's see, first we'll be here to, the values have already been given, and so we plug them into the point slope form and we write the equation of the tangent line. Now we'll be able to evaluate f of -3.1 using the tangent line equation. And that result is 3.8. It's approximately equal to the function value. Next, we see collaborative practice where students will work in pairs or in small groups to use the linear approximation now to evaluate some cube root functions. And so step 1 will be finding the function value at 64, which gives us the cube root of 64 and is 4. Then we take the derivative of the function and evaluate it at 64, and we get 1/48. That gives us enough information to write our tangent line. So with our tangent line now, we can evaluate f of 63 using the tangent line equation, and that gives us our result, 3.979. Next will be independent practice, and here students will have the opportunity to solve these problems on their own, and once they finish solving, we can refer to the next couple slides for their solutions. So solutions are on the next two slides, which we'll walk through together, and students will write their corrections if there are any errors, or confirm the answers if they got it right. So this is our first independent practice solution. And then our second independent practice solution will be this solution here. And if students have any questions, we'll discuss. In the absence of any questions, we'll wrap the lesson up. And here are a couple of references that I consulted for this lesson. Thank you for watching, and I hope you enjoyed it.